What is vacuum? Anybody? Yes?
Nothing.
Nothing is exactly right in one. Very good. Vacuum, the absence of matter. So if a vacuum is nothing, how does it do anything? Okay? And what this is balance versus imbalance. So before I tell you about balance versus imbalance, I have to tell you what it is that's being balanced. Why we're not all subject to the awesome power of vacuum right now. Okay? So if you look up, you see the ceiling. If you go outside and look up, what do you see? Sky. Sky. How far? Way up there. There's about 15 miles of atmosphere sitting over your head. And even though air doesn't weigh very much, 15 miles worth of air weighs a fair amount. How much? Well, if I had 20 gallons and I stacked them up on a sheet of paper, that's how much pressure you'd have. Or you could take one elephant standing on 2 square feet. So that's an elephant doing one of those foot stands, because each foot is about a square foot roughly, okay? So the elephant is up there like that. That's the same pressure as you've got from the air. Or you could have 2 escalades on 1 square yard, okay? Nose on nose, like that. That's how much air pressure that is. Dang. That's the balance that we're going to disturb to get the power of vacuum. So, how about your human body? Does anybody know what the area of the human body is? If you're Dan Soley, it's about 2 square meters. If I take the smallest person in this room, it's about 1.5 square meters. That's a pretty large area. Square meters about a square yard. We had 2 escalades standing in a square yard. So what this works out to is 11 elephants standing on it. Does anybody feel the 11 elephants? Balance versus imbalance, okay? So for balance, I'm going to have 2 people pushing on me, and I want to make sure it's balanced, so I'm going to ask John Pender and John Pender to come down and help me out with this, okay? So they're both John Pender, so it's got to be balanced. One on one side, one on the other. Push on my shoulders. Okay, am I going anywhere? No. Are they pushing? I'm feeling those 11 elephants. I'm feeling those 11 elephants. Okay, you guys can let off. Okay, now we're going to ask the first John Pender to step away. And we're going to do it again with the second John Pender. Go ahead, same force as before. What happens? I move. There's now an imbalance. Thank you very much. So now we're beginning to see what the power of vacuum is. It isn't really the vacuum, it's the absence of the atmospheric pressure. This little sheet is about 5 by 6. That's 30 square inches. 30 times 15 is?
45.
450. Thank you very much. Okay. 450 pounds. Smooth the air out so that it can't get out. Yep. This big guy, even more area, even more force. Finally. How many of you guys play table tennis? Not ping pong, table tennis.
Table tennis.
What's the hardest serve you've ever seen? World champion serves clock in over 100 miles an hour. Pretty fast, hard to hit. You betcha. Okay. Does anybody know what 100 miles an hour in terms of Mach number? In terms of the speed of sound? It's not that much, exactly. It's about 0.12 Mach. How about we take this tennis ball and we rev it up to 0.5 Mach? Maybe 0.6 Mach. Yeah. How are we going to do it? Vacuum. The awesome power of vacuum. Yes.
One down
that side. One down this side. Where'd the ball go?
Oh, hey! There it is. There's the hole.
Where did the ball go? So, ordinary aluminum can. I'm going to put a little bit of water into it. Yep, but another. And when you heat water, what happens?
It boils and evaporates.
What happens when it boils?
It evaporates.
It doesn't quite evaporate, it expands, it turns to steam. And that steam expands and it pushes the air out. And so then if I stop, well, there's just the steam inside, and suddenly cover it so that the air can't come back inside, what's going to happen?
Vacuum. No, it isn't.